Hello, this is Mr. N, and today we're going to talk about the intermediate value theorem. So, let's go ahead and read this. Suppose f is a continuous function on a closed interval ab, and let n be any number between f of a and f of b, where f of a does not equal f of b. So basically, f of a is here, f of b is there, they're not on top of each other to end up with a horizontal line. Then there exists a number c in this open interval from a to b such that f of c equals n. Well, let's examine what this really means. So let's do this on the side over here, and we will draw another situation. Here's the graph of the basic concept, but let's go ahead and explain it in a little bit different way. So suppose I had some graph here, and here is my x, there is my y, and I'll put an a value there, and let's put it right here. And this would be my f of a, and let's put some b value right there. And we can put it up here. It really doesn't matter, but in this case, let's put it up higher since I made f of b larger in my graph here. And let's take a look at this. Now suppose, remember what continuous means. Continuous means that I'm going to go from point A here to B without picking up my pencil. So I'm going from A to B without picking up my pencil. Now, here's the thing about the intermediate value theorem, is I'm going to draw some value n. You could put it wherever you want, but it's got to be between, right here, f of a and f of b. So I'm going to put some value n here. Now, how can I get to this from this point to this point without crossing n? Well, I can try to go up and maybe come really close, but then come way back down. I can't. I have to at some point cross n. And that is the basics of the intermediate value theorem. So anytime you're going from this point to this point, you will end up crossing in between at some value between f of a and f of b. So those are the basics. So no matter how I connect these, I can go up like this and down. I will at some point have to cross n. And this will give me a corresponding value down here that we can call c. Now, in this graph right here, you can see that it can happen more than one time. You can cross this value more than once. So that's the basics of the intermediate value theorem. So all it's really saying is that if we have a continuous function, it will take on all values between f of a and f of b. The above graph, this one, is continuous and illustrates this intermediate value theorem. So in other words, again, if I'm going from a to b and I have to connect a to b, I have to have some value in between here, just like I have a value in between here. So this is that intermediate value such that f of c equals n. So here's my c, this is my f of c, which equals the n value. Again, one more time. If I have a value in between here, I gotta have a value in between here. Since it's continuous, there's no way to connect these 2 points without crossing this line. You can draw this in any other scenario. You could draw a negative scenario. Put f of b below f of a. Same thing will happen. So in every scenario, this is what's going to end up happening. It seems so obvious that yes, you have to cross this line. So since it is continuous, you will have at least one value between f of a and f of b. It's also important to note that the intermediate value theorem only states that the function will only take on some value of n. It doesn't tell us where n is going to be. It just says n has got to be somewhere in between f of a and f of b as long as c is between a and b. So how do we do examples on this? How will you see this? Let's look at this first basic example. Let's slide this up and take a look and continue on. Okay, so in our first example, we are asked if there is a root between -1 and -2 for this function, and explain how we know. Well, let's first find what f of -1 is. When I plug -1 into my equation, I get negative 1 cubed minus 2 times negative 1 squared plus 5. This gives me an answer of, this becomes negative 1 plus 2, or negative 1 minus 2 plus 5, which gives me a value of 2, which is a positive value. When I plug in f of negative 2, this ends up being negative 2 cubed minus 2 times negative 2 squared plus 5. This gives me negative 8 minus another 8 plus 5, which will end up being negative 11, which is a negative value. So if I look, and if I have right here negative 1 and then negative 2, and from negative, the value at negative 1 is positive, and the value at negative 2 is negative. Well, to get from a positive to a negative, what must I do? I must cross the axis somewhere. So because I cross the axis, I know that there will be a root. So there must be a 0 between negative 1 and negative 2 by the intermediate value theorem. And that's what tells us that we must have a 0 between a positive and a negative number. Okay, now looking at number 2. It says the functions f and g are continuous for all real numbers. The function h is given by h of x equals g of f of x plus 5. And that means we need some h of x column, and I don't have that h of x column. So let's go ahead and write in that h of x column, because look, one of my questions deals with h of x. In this case, it's h of r. So let's go ahead and put in this h of x, which is the g of f of x plus the 5. I'm going to give myself a little bit more room here, sliding out. And let's just do this first value, h of 1. That is going to be g of f of 1 plus the 5. Well, g of f of 1 ends up being f of 1 is 5, so this becomes g of 5 plus the 5. And g of, let's take a look here, g of 5 gives me 1, so this will be 1 plus the 5, which is a value of 6. So we do the same process, and let's just finish this table. We do the same process for the rest of these right here. Again, you're doing the f of 2, which is 4. Now g of 4, which is 3, and add 5 to it, you'll get a value of 8. So this one ends up being 8. And I'm going to just go ahead and just do a little erasing here. I don't really want all that in there. So let's try it one more time, and we'll continue on. It's fine. This is the 6. Now I do the same process here. I will find h of 3, and I end up with 5. I will find h of 4. Again, to summarize this process, h of 4 means f of 4, which is 2. Now g of 2, which is negative 1, and then I add that 5 to give me a value of 4. And finally, I'll do the last one, and I end up with negative 1. So here is my table. Now let's look at this question. Must there be a value r where r is between 1 and 3, such that h of r equals 2? And explain my reasoning. Well, if I sketch a quick graph of what is happening here, and let's just go ahead and slide all this up a little bit, and we'll draw this graph right here, and just a quick sketch of what's happening, I end up with when x is 1, h of x is 1, 2, 3, 4, 5, 6. If x is 2, h of x is 8. And when x is 3, h of x is back down to 5 right there. And then when x is 4, h of x is also 4, and when x is 5, h of x comes down here to negative 1. So now take a look. Again, all of these must be continuous because it says continuous. So somehow I have to connect all those points without picking up my pencil. So when I go from 1 to 3, from here to here, must there be an h of r that has a value of 2? So when I go from up there to there, do I ever get to a point where the h of r is 2? Look at where the 2 is. H of r being 2 is right here. This is at 2. Will I ever cross that? Do I ever have to cross that when I go from 1 to 3? No, I don't. So in this case, no. There does not need to be a value such that h of r equals 2. And again, what is our reasoning here behind everything? IVT. Let's take a look at the next one. On the next one, it says, must there be a value r between 2 and 4? Now I'm looking between 2 and 4, so from here to here, such that h of r is 7. Well, so if I'm at 2, I'm up here at 8. Remember that this is 8. And when I get over here to 4, I am at a value of 4. So let's draw a line across at 7. This time I'm going to choose a different color, and we will draw that line across at 7 right along there. Okay, there's 7. So now for me to get from here, okay, to the next point here, so for me to get into this interval from 2 to 4, here's 2, there's 4. If I'm going from here to here, will I have to cross that 7? Is there any way to get from here down to there without crossing the 7? No, there isn't. So yes, there must be a value such that h of r equals 7. So in this case, again, by IVT, there must be a value such that h of r equals 7. And again, we showed it. So if I connect from here down, this is at 2, here's at 4. If I connect, I must cross this 7. So no other way. IVT says I have to cross it. So yes, there must be a value there. Now let's move on to our last example. Again, numbers 1, 2, and 3, this last one, this is how you might see things on the AP test, especially on number 3. This is the type of question they like, even though when you first learn IVT, you don't learn how to do all these parts, but we're still going to talk about them right now. Okay, so let's read over this problem. It says, let y equal f of x be a differentiable function. Right away, I know that since it's differentiable, that means it's continuous. Continuous. Okay, so we are looking at a continuous function on negative 8 to 4 such that f of negative 8 is 3, f of negative 1 is negative 3, and f of 2 is 6. What is the minimum number of zeros this function can have? Let's sketch out what's going on here. So let's quickly draw a sketch of our situation. And we've got from negative 8 to 4. 1, 2, 3, 4. And over here, f of negative 8 is 3. So we're at this point. F of negative 1 is negative 3. So f of negative 1 is negative 3. And f of 2 is 1, 2, 3, 4, 5, 6. F of 2 is 6. Right up there. So we've got these 3 points. What is the minimum number of zeros this function can have? Again, it's continuous. So we think of IVT. In this case, I have to go from this -8 value all the way over to here. So that means I got to connect this point to this point to this point. Well, look at, here's my 0 line. In order for me to get from here to here, this is at f of -8 and this is at f of -1. What must I do? I must cross the 0 line. In order for me to get from f of -1 to f of 2, what must I do? I must cross the 0 line. So I've crossed the 0 line at minimum 2 times. It could have done more, but here there's a minimum of 2 times. So in this case, we will say that there must be a minimum of 2 zeros by IVT. Is there a value of x for which f of x equals 2? Well, I need f of x equals 2. So let's go ahead and draw this dashed line here at 2. This is what I need it to be. So is there a value for which f of x must equal 2? Yeah, because again, this is continuous. So for me to go from here to here or from there to there must be an f of x equaling 2. So yes, again, by IVT. Does f have any horizontal tangents? So taking a look at this, since it is differentiable and continuous, Rolle's theorem in this case tells us that yes, there must be at least one horizontal tangent. Okay, taking a look at part D now. If f has only one extremum on 8, 4, will it be a maximum or minimum? So from 8 to 4, if it only has one extreme value, if only one extreme value, if only one, it has to be this minimum. It must be this minimum. You can't have it if there's only one. Again, that's the key to this question. If there's only one, there must be a minimum, and it's going to be that point. So there must be a minimum. So thanks for watching, and I hope you learned about IVT today. And again, in the next videos, we'll be talking more about Rolle's theorem, continuity, and getting into the mean value theorem as well.